Alright, we're going to try one more, a little more in depth of logarithmic differentiation. Before we get there, let's go over our log rules so we're all in the same place. So, ln, if we had two functions, a times b, we could rewrite that as ln a plus ln b. If we had two functions, a and b, a divided by b, that could be the same as ln a minus ln b. If we had something raised to the power, ln a to the k, that would be the same as bring it in front, k times ln a. We should also just make note from our last video that the derivative of ln f of x is 1 over f of x times the derivative of x, which would look like the derivative of x over the function of x. Alright, moving onward, there's a way that we can derive logging the entire equation, and sometimes it's easier, sometimes it's not. Let's go over one where, say, it's probably easier to do it this way. F of x equals x to the x. We don't really have the rules to do that, but we could solve it using logarithmic differentiation. So, let's log both sides, or ln both sides. So ln of f of x equals ln of x to the x. So we see this rule right here. When we have x to a power, function to a power, we can put it in front. So ln f of x equals x times ln x. So now let's derive both sides. Deriving the first side, so now derive. We know that the derivative of ln of f of x is the derivative over the function, and then that's equal to the product rule on the right side. So the derivative of the first term, which is x, would be 1 times ln x, plus we would have x times 1 over x. So we know that simplifies to ln x plus 1. So we're solving for just the derivative, so we'll multiply by the denominator on both sides. So the derivative is ln x plus 1 times f of x. So we need to go back to the start of our problem and see that f of x is equal to x to the x. So that would be ln x plus 1 times x to the x. And that's good enough. You can factor it in, or you can leave it just like that. So this is a time where it's probably advantageous to do logarithmic differentiation. Here's a time where you could probably do a simple power rule, but instead we'll run it through to show that this method works. So new problem, we have f of x is equal to 3x to the third plus 2x. Alright, let's take the log of both sides. So ln f of x is equal to ln 3x to the third plus 2x. We see there's no rules that we can do here because there's two terms that are being added, not being multiplied or divided. So with that, let's take the derivative of both sides. Derivative over the function on the left is equal to 1 over, so it'd be this kind of the same thing, right? 1 over that function, 3x to the third plus 2x, multiplied by the derivative, which would be 9x squared plus 2x, plus 2, I'm sorry. Just to rewrite it really quick, the derivative over the function is equal to 9x squared plus 2 over 3x to the third plus 2x. Multiplying by the function on both sides so that we solve for the derivative. Get 9x squared plus 2 over 3x to the third plus 2x. We multiplied by the function. And looking back at our problem, the function is 3x to the third plus 2x, which is the function right there. So because they're the same, we can cross them out, and the derivative is 9x squared plus 2. We could have done that in one easy step with the power rule. Going back to our problem, we'd have 3 times 3 is 9x squared, and x to the 1 would just be the number. There you have it. So it's at your discretion which one you like depending on the complexity of the problem. I think I have one more here that we can go over. So something crazy involving, I guess, power rule, quotient rule, product rule, would be a lot. So we can say f of x is equal to x squared plus 3, that quantity to the third, times 2x plus 5 to the 1/2, which is the square root, over x to the 5th plus 7. So step 1, we have to natural log both sides. Ln f of x is equal to ln of our function, x squared plus 3 to the third multiplied by 2x plus 5 to the 1/2 over x to the 5th plus 7. Alright, let's get after it. So let's derive both sides. Let's break up the right side first into multiple, so we have an easy addition rule instead. So just keep the left for now. So we see that the two top terms are being multiplied by each other, so we can rewrite it as ln x squared plus 3. We see that's to the power of 3, so we can put it in front 3 times. Plus, we have 1/2 here, 2x plus 5. 1/2 times ln 2x plus 5. And then we have to subtract our what's being divided, ln x to the 5th plus 7. So with that, now let's derive. So we have f of x derive. F of x over the derivative of x is equal to 3 over x squared plus 3 multiplied by the derivative of the denominator, which would be 2x, plus 1/2 times 1 over 2x plus 5 times 2 minus 1 over x to the 5th plus 7 times 5x to the 4th. Let's clean that up a little bit. F of x over the derivative would be 3 times 2 is 6x over x squared plus 3. 1/2 times 2 is 1. So we have 1 over 2x plus 5 minus 5x to the 4th over x to the 5th plus 7. So, sorry here. This is the derivative over the function, the derivative over the function, or else we'd be all wrong. Alright, so now multiplying by the function, we would get the derivative is equal to, in parentheses, this quantity. And you can see how crazy this would have been if we did the quotient rule or incorporated the product rule and everything. So personally, if I were to do this one, it'd be this way. Times the function, and our function is right here. Take this, See if I can copy that. F prime of x is equal to, geez, nope, doesn't like me. Well, just to have it out, 6x over x squared plus 3 plus, so rewriting 2x plus 5 minus 5x to the 4th over x to the 5th plus 7 multiplied by that function, zoom out, x squared plus 3 times 2x plus 5 to the 1/2 over x to the 5th plus 7. And there you have it, some crazy function that you could FORL out if you wanted, but it's perfectly fine how it is. And there you go. Circle our answer. See you next time.